This tutorial is to show you how to draw resonance structures. So remember, resonance can occur when there is a double bond or triple bond that can be placed in more than one location in a Lewis structure. So we have to draw all the Lewis structures that show where that double or triple bond can be placed, because in reality that those bonds are an intermediate between a single double bond, and we have to show that with our resonance structures. So the first example is carbonate. So you're going to just draw the Lewis structure like you usually do. We start with our available valence electrons. So we have 4 from carbon, 6 from each oxygen, and because of this -2 charge, we have to add on 2 electrons. So we get a total of 24. Then you're going to take these available valence electrons and place them in your Lewis structure. So we're going to start with our central atom, which, because carbon is present, is going to be carbon. Carbon loves to be the center of attention. So we're going to put carbon in the center with our oxygens surrounding it. We're going to bond them and then fill in our lone pairs to make sure that every single atom in the structure has its full octet. So the point is, when atoms bond, they are bonding so that this carbon, this oxygen, and this oxygen have their full octet stable electron configuration. And for most atoms, that number is 8. So I'm going to draw in some lone pairs. Now notice that I have drawn in lone pairs to make sure that all of these atoms have their full 8 electrons around them. But if I count up how many electrons I've drawn, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Uh-oh, because I can only use 24 in the structure. Well, that tells me that there's going to be a double bond here. So I'm going to erase these lone pairs off the central atom because they never exist. And I'm going to erase some lone pairs off of one of the oxygens. So this is the correct structure. I have a double bond here, and so I only have 1, 2, 3, 4 extra electrons around this oxygen. Every single atom has their full octet, but with resonance, we can actually place this double bond between this oxygen and carbon, or this oxygen and carbon, or this oxygen and carbon. So there are actually 3 resonance structures. So you need to show the 3 resonance structures by drawing where all the double bonds can be placed. So here are the 3 structures, resonance structures for the carbonate ion. They show that the double bond can be placed between any of those 3 oxygens and carbon. So that is how you draw that resonance structure. So here are 3 other compounds that have resonance structures, so I'm going to draw those for you. I have drawn the Lewis structures, the resonance structures for this molecule here. Notice that this time there are only 2 resonance structures. That is because hydrogen cannot form a double bond. Remember, hydrogen is an exception to the octet rule. It only wants 2 electrons around it. So for the resonance structures here, there's only 2, because there can be a double bond between carbon and this oxygen, or a double bond between carbon and this oxygen. If we were to go and label the molecular geometry and the polarity of this molecule, that's something that you still need to be able to do, this is what we would get. All right, so the molecular geometry would be trigonal planar, because if you look at both of the resonance structures, there are 1, 2, 3 areas of electron density around the central atom carbon. So that gives you trigonal planar. And the polarity of these molecules is polar because look, even though carbon does not have any lone pairs, the atoms surrounding it are different. We have one hydrogen here, one oxygen here, one oxygen here, so that makes the distribution of electrons uneven. So there is a negative and positive end. It is a polar molecule. So we're going to draw one more resonance structure, and that is for sulfur dioxide. So I've already figured out the available valence electrons, 18, and I'm going to put sulfur in the middle because it is the least electronegative. So sulfur will go in the middle, and then there's going to be oxygen and oxygen. I'm going to bond them, and then I'm going to fulfill the octet for all of the atoms, sulfur and the 2 oxygens. If I do that and I count up the number of electrons I have just drawn, I have drawn too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that lets me know I do need a double bond. So here is the correct Lewis structure. But because there are 2 places where I can place this double bond, there is another structure, the resonance structures. So I can place that double bond on the other oxygen. So resonance just means you can move that double or triple bond within the Lewis structure, so you have to show all the correct drawings. And then finally, the molecular geometry for the structure is bent. Yes, there are 1, 2, 3 areas of electron density, but because there are only 2 bonded regions and only 1 lone pair, it is bent, so it looks like this. And then the polarity of this molecule is polar. We have lone pairs on the central atom, so the electron distribution is uneven.